So my name is Sandra Gesing, and thank you very much for the possibility to do this recording of my talk. So I will talk about increasing developer productivity by assigning well-defined roles and teams. And I try, yes. So first of all, I wanted shortly to talk what is developer productivity, what do we understand about it? And my takeaway is that it's much better to measure something like impact or software sustainability instead of going for counting lines or number of solved bugs or working hours. I mean, I tell, for example, students always, and I got that from a colleague, I really like it, solved bugs is a good thing. There's nothing bad about, because it means also that you found something, especially if you solve a bug when someone contacted you because you brought maybe something into GitHub, someone tested it. And if someone comes back to you and says, oh, that is fantastic, I really want to use it, but this is not working for me. This is positive news. First of all, they tried your software. Second of all, they were so engaged with the software that they even come back to you. So I still think that number of solved bugs is a great thing, but using it as a measurement for developer productivity is a bad thing. Because I refer to this nice comic strip. So yeah, the goal is to write bug-free software, not that we are capable of doing that, by the way. I would never expect to have really bug-free software. So, and to telling developers that they get a bonus for every bug they find and fix in their own software is self-explanatory, or that this is not a good thing. We don't want to go there. So I have two use cases. So there's the HUBzero team I'm also working part-time for. And I will talk about the Center for Research Computing, two teams. And if we look at the HUBzero history, the operating model path, so it started already 14 years ago with Punch, a precursor to NanoHub. It was a product to really support nanotechnology, to have services in a web browser and an intuitive user interface. Then there was the NSF funding for NanoHub in 2002, and then HUBzero spun out of NanoHub in a way that it was not only for nanotechnologies, but a framework really for a lot of different domains. And it had this, since 2015, this diversification as self-funded sustainability. So Hub's hosted by Purdue, that was how it started. It moved to San Diego last year, and it had foundation members running their own hubs. Foundation members means really people who were paying into a foundation for HUBzero, and then have some maintenance hours from the team and different roles, so different support from the HUBzero team, and they are open source hubs. This was really driven by key team enablers. So that is the other thing we see with teams in academia. Successful teams really need like an evangelist, someone who has a vision what he wants to do in the next years. And so what happened is, so the group moved to SCSC last year, and it's a software, HUBzero is a software framework. And what the team really, to increase the productivity, they have all different roles, from cybersecurity to web programming, user experience design. I won't read it all, but you see very clearly that there is this division of roles, and of really being able to focus on one role for one framework. And that works well if you have a product you want to develop. And we are servicing over 2 million total visitors annually, and it's entirely self-funded. So the software sustainability and the impact is high. And these are all the collaborations and integrations. You can see that is another strategy of HUBzero. to work with a lot of different products which are also used by researchers. So these are examples that are coming over. At the moment, there's a Docker integration. So you see that it's also focusing. Developers can have a look what kind of products they want to integrate into the framework. And then they develop this architecture, for example, with Boink and Docker. And I don't want to go into details for the architecture, but you see the possibilities in the roads, that it's also interesting for developers to have, to have a look what they really want to do in this framework, and that a lot of different roles they can focus on. And I think a happy developer is also always a more productive developer, and having this possibilities to be part of the design and decision process. If you look at the Center for Research Computing, there are different roles. Not the same because it's not one framework. The Center for Research Computing supports different things. It supports software development and profiling, cyber infrastructure, science gateway development, and there's computational scientist support. And that is, for example, a role so that looks at funding that are people like me. So I'm a computational scientist at the Center for Research Computing. So I'm writing proposals, I have my own research, I have collaborative research, and with computer science and engineering with other departments. And this means I bring money in and I contribute to the design. And I work closely with the research programmers or research software engineers, but I'm not implementing myself anymore. So the CRC has also system administration and prototype architectures. Like, for example, we have more than 25,000 cores. We have storage resources. We connect to national resources with Exceed. And we have more than researchers, research programmers, and HPC specialists. And how it started, to show a little bit the process. So there were first in 2006 to 2008, there were 7 FTEs centrally funded. And this was HDC, HPC computing and basic user support. And 80% centrally funded hardware and around 300 active users to give an impression of the impact. But there were no other kinds of research computing services. And social sciences and humanities were definitely underserved. And on campus, there were around 1,000 faculty and 12,000 students, which is nowadays still the same way. Yeah, okay, at the moment, they are not on campus. They are working remotely. What can I say? That is the time we are in. But that was the start. And so the mission was that we really engage in computational science and foster this multidisciplinary research and advanced computational tools and services. And across all the different disciplines. And the vision was also really to be not only on campus recognized, but internationally recognized as an instance for novel applications and cyber infrastructure. So the CRC director thought was like, okay, he developed the vision, by the way. But now what is the way to get there? And what should we do first? And he had 7 people. So HPC works fine, it was well defined in the road. So and then he came to, we need portals, collaborative environments. We need a good user support and, good straight resources and usage policies. And all these different aspects of HPC and cyber infrastructure that they can work together. So there were a lot of questions. So Jarek Nabrzyski, so his goal was, okay, I will start with the process and I take the risk and hire people first and train them to generate and bring projects. So he brought first the projects and incite people to project and focus on getting more projects and more people. And if he wouldn't be successful with his vision, so that slide is from him, he said, okay, then I have to quit. And I think that is also a little bit this notion of the impact and how to achieve something. And also you see here, you need an evangelist who's really behind an idea. So unfortunately, we had many projects. So I work for the CRC, so it's still, existing, and he's still the director of the CRC, so all is good. So in 2020, now we have from 7 FTEs, we have now 50 FTEs, over 50, and 70% of the staff salaries are supported through grants and services. So the role of having people in a computational scientist role really worked out for the team to bring money in, to do the research. We are supporting now 30,000 cores. We developed from 300 active users to 2,200 active users. We have 12 HPC engineers and user support staff, and 25% of compute nodes are now centrally funded, not 80% anymore. So the sustainability comes really in with the funding we are getting every year with all the cyber infrastructure projects. So there's this collaboration with 35 faculties, and we have about 25 research programmers. And the role of the research programmers is really that they can work together with the computational scientists and looking at the different aspects. So their role is to be in the development process. And if they're interested in the back end, in the front end, they can look at different projects in a way, which domain they feel comfortable with. For example, we have a couple of people who are mostly doing the bioinformatics projects, or we have people who are always on the user interface side. So there's some degree of freedom how to work together. Of course, everyone needs projects, so that means it's not always a wish list they can fill out. But of course, there is this in the role, if they are really happy to do the back end or the database connections or certain designs, then often the same people do exactly this for the different projects. Or if they're really good and always want to directly, they're all really good, but they're good in the communication with the PIs and everything. So then they do that, and we have a Scrum process and a product owner, and these different product owners have then the different projects. And we are still serving the same number on campus, 1,000 faculty and 12,000 students, but we have many more projects and active users by now. And this is also has contributed to the sustainability and to impact, of course. Having these roles with a really dynamic infrastructure and project development and agile development. And this is all from me. Thank you.